Yes, sir.
Yeah. So we were doing this question and the time was up to get it. Right. So we understood all these currents, right? How did we name them and how did we represent all these currents? So we started with this one I1 and then this one I2. And then I3 is coming back and then I1 is coming back. So first was this. Then we named this I2 and then the rest were according to the current. Right. So how many unknowns do we have in this circuit?
3.
Right.
No,
So yeah, three. I1, I2, and I3. Yeah. Right. Correct. You are correct. And for three unknowns, how many equations? Yes. How many equations do we need?
3.
Right. So we have to find all these three equations and then solve. So let's say that we have to apply the Kirchoff law, right? So to apply the Kirchoff law, the first thing we do is that assume a loop, right? So we can have at least these three, right? There can be more loop like this bigger loop, but let's say that we only need three equations. So we will assume only three loops, right? One, two, three. So let's say this is positive terminal. So let's assume that current is okay. And for this one, let's say that this is okay. And let's say for this one, this is so first part is done. We have assumed the right. So we have three closed loops. So Saad is not here. So first, I will do, and then second, Aisha, and then third will Mariam will do. So let us do the first circle. Let's say that the first one.
Sir,
Yes, yes, sir.
sir, the loop's direction can be anyhow, sir.
Yeah. So it can be in any direction. So whenever let's say that you have calculated this, right? So if you get the opposite direction, so the current would be negative, right? Okay, let's say that you calculate I1, I2, and I, right? And let's say that one of them you found out that this is, which means that we have assumed the incorrect loop, so we have to correct the direction of the current, right? So we can choose any direction of it, but ultimately the final answer will correct our assumption. Understood? Yeah. The current could be following in this direction also. But when we solve the loop, so then we will see that what are the direction of the current. If one of them is negative or if two of them is negative, then we can see that, yeah, this current direction. In this way, actually, so we can change things, right? Yeah. So the answer of your question is that we can assume any direction of. Understood? Okay. So let us let me name the this is A, this is B, and this is okay. So first loop is A B B. So A B, right. So this is the resistance, and we are going. This is the loop that we have assumed, and the current is going in this direction. So what would be the voltage? Yes, correct.
1.
Plus or minus.
-1.
Minus I, right? I1 and then this 1 omega. So 1 into I1, right? The voltage is IR. So current is I1 and resistance is 1. So I, right? And minus because we are in the same time. Okay. So now what do we have? This one. So this voltage supply. So what would be here? This is 10 volts. So what would be here?
Plus
Yeah, that's correct. And then we are coming to this part. So the loop is in this direction. Resistance is 4 and current is out. How much would be?
minus IR.
Minus IR, which means minus 4 I, right? And then we get back to this part. So this is the loop, and the current direction is also the same. So what would be the voltage? Yes.
2.
So
Minus
minus 2 and current is how much? I2 plus I.
I2 plus I3.
Now we have come back to the initial point. A. We have come back. Understood, guys? Yes.
Yes.
So this would be I1 plus 10 minus 4I2 minus 2I2 minus 2I3 and then so this is minus 4 minus 2 so minus 6 minus I1 minus 6 I2 and minus 2I. This 10 goes in the right hand side and become minus 10. So minus 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 we take common. So this would be minus 6I plus 2I and then this is minus. Minus minus cancel. And we have first equation which is this is the first equation. Okay, now Aisha, your turn. So let's say this is the so in loop A, B, C, and A. Okay, so let's say we are starting from here. So what would be the voltage we are starting from here? Yeah, so we are starting from here and this is in the direction of
-1.
yeah minus I1 and then for this part for this
Plus,
part
plus 10.
plus 10 and then we are coming. This the loop is in this direction, right? And the current is in this direction. So what should be the voltage?
-1.
Yeah, minus 4 and current is
All
I1.
of us.
This is 8 and then we are coming. This is the loop. Okay. And the current direction is opposite. So what would be the voltage?
Positive.
Positive 2 into the current. 2 is resistance and current is opposite. I2 plus I3 minus I. So then the circuit is completed, right? So this is right. Is that clear, guys?
Yes.
So now let us solve this. So these questions are very lengthy, so we have to practice a lot. And these are asked in 5 or 6 mark questions. So please do this calculation on your own and practice. Practice these questions. Okay, so this would be how much? This is minus I1, minus 5 I1, and to minus 7i. Okay. And now we have minus or plus 4i2 plus 2i. So plus 6i2 and then plus 2i. And minus of 10. So again, we take the negative common. So this would be minus common 7i minus 6i2 and minus 2i and minus minus cancel. And we have this equation 7i1 minus 6i2 minus 2i. So this is our second equation. Here, guys. Now, you guys note that we are going from here, right. So first we write and then we are going. We write it, right. So, Maria, wrote that. So we are going from in loop, let's say B, and we are going from here. So we are going to B, right. So you tell me that this is the current direction and this is the direction. So what would be it?
Minus I2 plus I3.
And this resistance of minus resistance into current, which is I2 plus I, and then this one. So we are in this direction, right? Loop is in this direction, current is in this direction. What would be the voltage?
Minus 2 into I2 plus I3 minus I1.
And then the last. So this would be how?
Plus 5.
Absolutely. So all the circuit is completed, right? Now we solve the minus 2i2 minus 2i minus I2 minus 2i plus 2i, and this is minus 1. We have 2i1 and then what? So minus 4i2 and minus of 2i3 minus 2i3. This is the minus. This is the third equation. Right. This is the third equation, and now let us write all the equations. Okay. So first one is I1. No. First one is I1 plus 6i2 plus 2i, and this is 10. Okay. And then we have this is the first equation, and then we have 7i1 minus 6i2 minus 2i. This is our second equation. Right. So do you guys remember how do we solve the linear equation in C variable? Have you solved the equation? Yes.
No, sir.
Okay. You have not solved. So the method that we will do is the elimination method. Elimination method you guys are familiar, right?
Yes, sir.
Yeah. So we have to eliminate one by one variable, right? So let's say that if I remove this I3 variable, we have three equation, I remove I3 variable. So then how many variables would be there? Two variables, right? I1 and I2. So let's first remove the I3 variable. So you guys carefully look this first and second equation, right? So from first and second equation, how can I remove I3? Yeah, how can I remove I3? Just look here and let me write this one and you guys tell me whether it's correct. So if I add this one, this equation and this equation, 2I3 plus minus 2I3, this would be cancelled, right? Yeah, so that is how we can eliminate this item. So this is I1 plus 6I2 plus 2I3, this is 10, and this is 7I1 minus 6. Okay, so this one is also cancelling. So then it is getting okay. Luckily, this is getting cancelled. This is 10. So if we add these two, right? So this would be minus, right? So the sign doesn't change. So let's keep the sign. So this is cancelling. This one is also cancelling. This is 8I1 and this is 20. So I1 would be 20 divided by 8, which is 5 by 2. So I1 is 5 by 2. Yeah. Understood, guys?
Yes.
Otherwise, if this was not cancelling, so what we have done is that only cancel this one, and then from first and third we cancel again this one. So I3 would be getting cancelled, and then we use two variable equation. So this was the idea, but luckily this I2 is also cancelled. So our work is getting correct. Okay, this is I1. Now let us put the value of I1 in both the equations. Okay, let us put the value of I1 in equation 1 and equation 2. So putting, now we are coming back here. So you guys see be careful with the direction of calculation. So putting the value of I1 is first and in let's see, one. So this would be how much? 2 into I1, which is 5 by 2, and with minus of 4I2 minus of 4I2, and this is minus 1. Okay. So this would be, this is plus 5, so minus 4I2 and minus 4I3. This is minus 5 minus 5. So minus 4I2 minus 4I3. This is minus. I take minus common, so this is 4I2 plus 4I3. This is 10. I can also take 2 common. So this would be 2I2 plus 2I3, and this is 10. So I2 plus 2I3 is 5. Okay, so this is my fourth equation. Right. Now putting the value of I1 in 1, so this would be how much? 5 by 2 plus 6I2 plus 2I3. This is 10. So this would become how much? So you guys can see that this is a very lengthy problem. So 6I2 plus 2I3 and 10 minus 5 by 2. So 6I2 plus 2I3, and this is 20 minus 5, so 15 by 2. This is my fifth equation. Okay, I have fourth equation and fifth equation. So using fourth and fifth. So from fourth and fifth, what should we do? Should we add these two or subtract these two? One of the variable we have to cancel. So what should we do with these two equations? Yes, guys. What should we do with these equations?
Add.
Add. So if I add them, this would be 6 plus 2, 8i2, and this would be 2 plus 2, 4i3. So nothing is getting cancelled. We have two equations and we have to cancel one variable. So how should I or what should I do? Because in elimination method, we have to get one coefficient, but already the coefficients are. So we can subtract them, right? Subtracting fifth or subtracting fifth minus fifth. I should write subtracting 4 from fifth. You guys, yes. So this would be how much? This would be 6i2 plus 2i3 equals to 15 and 2i2 plus 2i3 is equal to 5. So subtracting, right? The sign will change, this will get cancelled, and this is 4i2. And this is 15 by 2 minus 5. This is how much? 4i2 is 15 minus 10 by 2. So this is 4i2 is 5 by 2. So I2 is 5 by 8. Clear, guys? Yes, clear. Guys, clear.
Yes, sir.
Okay, so if we have calculated I2, so we can put the value of I2 is okay. This is we are putting the value of I2. So this is 2 into 5 by 8 plus 2 I3, this is 5. This is 4, so 2 I3 is 5 minus 5, 5. I3 is, this is how much? 20 minus 5. So again, 15 by 4, and then I3 is how much? So this is 15 by M. So these are the answers. We have calculated I1, I2, I3, and you see that all the three currents are positive. So which means that we are assumed the right direction. Is there any doubt? Yes, right. Is it clear or if you guys
No,
have?
sir.
So then you guys please note it down and please remember the direction. Because I was moving here and here, and first is this one. Okay, then we are going in this direction, and then you guys. Yeah, but whenever you guys need me to go down, then guys. And each question, so the question that I did earlier and this one, these are very important. So these are lengthy and yeah, practice to solve. Please note it down, and whenever you guys need me to scroll down the screen, guys. Yeah. So, yeah. Aisha, did you note it down? From here, remember from here we are getting, from here we are getting here. Okay, and then please remember the direction. Yes, whenever you guys do the
Sir,
done.
can you please put up?
Yeah, and thank you guys for coming to this. Otherwise, on Tuesday we'll have to. So now you guys are here, so we can complete this chapter. And from today we'll start the next chapter. And if you guys have any doubts, so you can also ask. Yes, should I scroll down like this?
No,
Okay. Down. Asha. Yeah,
Yes, sir. You can.
yes, quickly note it down because then we'll have 15 minutes left to uh, understand about this. Noted, guys. Uh, Noted, everyone. Okay, Mariam, noted. Yes, Mariam, noted.
No, sir.
Okay, please note it down and check. Okay, so the last topic of this chapter, and this is also important. So, very last topic. Okay, so what is this Wheatstone Bridge? The construction we will understand. So, the construction of this Wheatstone Bridge is that we have resistance and then this resistance, okay, and then the other resistance and, the right. And this circuit is connected. Here, this, let's say this is relevant. Have relevant. Okay. And it has some resistance. It has something. Now, this resistance is, let's say, R1, and let's say this is R2. Let's say this is R3, and let's say this is R. And the current is flowing in this direction. So let's say some current is flowing I, and this is I1, and then this is I2. Okay. And in here, this is, let's say, this is IG. And in here, we have, let's say, IG, and in here, let's say, we have, so this is IG, and then this is I. Okay. And then we are getting back Let's say this is the, so this is the construction of the gate storage. It is like a bridge, right? So this is a bridge, like this galvanometer is appearing to be a bridge. Like. So what is the use of this gate store bridge? The first is that it is so it is calculate unknown resistance. Okay, and there are two devices which are made up of this crystal. So meter bridge is based on bridge. Okay, and the third one, the potentiometer. This is a potentiometer is the device what oh you guys are using. So potentiometer is a device, right? This is also based on speed source. Right. So these are the three basic uses of the speed source. And the construction you can guys can write. Okay. So the construction is not you guys just draw this construction and write about it. Now okay, so now working of the gate storage. Right. I will quickly write the working on of how does it work? So first, what we do is that let us write all the equations that we have. So we have this one, and let's say this is the galvanic. Okay, this is height, and then or this is R1, this is R2, and this is R3, and this is R. Okay, and this is I1, this is I2, this is I3, this is I. So let us assume that these are this is one, and let's say this one is second. These are the two groups that. Okay, so all right, and now let's yeah. So you guys quickly tell me about this first, and so Aisha will tell me about this first look. I am so let's say let's name this as A. So in A B okay in A B T A, what would be the Kirchoff law? So we have this direction and the current direction is this one, and we have this direction and we have this direction. So Aisha, quickly tell me the voltage switch off.
minus I1.
I1, I1, R1, and then in here,
minus I
IG, and let's say the resistance is RG. Okay, now in this one,
plus minus
plus I2. R. Okay, so then it is equal to this one is the first equation. And in Mariam quickly, oh, so we have different things. in let's say B, C, D, B. In this loop, Mariam, tell me the voltage.
minus
Yeah,
IR minus
I3R, right? And then
I3R3
in this case, what would be
plus
the
I4R4
that's I4R4, and in here,
plus IGRG.
correct. So these are the two equations that okay. So these are the two equations that we have. And working of Wheatstone, which says that so this galvanometer, we set the galvanometer so that the current in this loop, so the current in this loop becomes zero, right. So in this case, Ig becomes zero. So we set the resistance of this node resistance such that the current on this loop becomes right. So, so which right, Ig is okay. So whenever we make the current of this direction equals to zero, right? So in galvanometer, we set all the resistance or all the resistance in this case so that this current becomes zero. So if Ig is zero, right? So the equivalent equation would be what? So this one be I1 R1 plus I2 R2 equal to zero. This is first. And then we have minus I3 R3 plus I4 R4. This is here, guys. So then we have this I2, or let me write as I1 R1 equal to minus I2 R2. So I R1 by R2 is equal to I2 by R. This is the first equation. And from here we have minus of I3 R3 and equal to minus of I4 R. So minus minus cancels, right? And then R3 by R4 equals to I4 by I. Is this clear, guys? Is this clear? Okay, so let me write the overall. So this is the overall picture. The current in this circuit has become zero, so we can neglect that. And this was I1, and this was I2. So if current in this direction is zero, so this would be equal to what? This is I1, so this would be what?
I1
I1 again, right? So this is I3, and again this is I2, which is I. So let's say this is third, and this is fourth. So I can write in place of I4, I can write I2, and in place of I3, I can write. So R3 is I2 by I. Let's say this is 5. So from here, so from third and fifth, right? What can we say? From third and fifth, what we can say? Yes,
R1 by R2 is equal to, and R3 and R4 are equal to the same thing.
yeah. This is the case for the V. Is that clear? So when we know R1, R2, and R3, so we can calculate the unknown resistance R. So this is the working of Wheatstone bridge. If you guys have any doubt, you can ask me. Otherwise, yeah, if you don't have any doubts, then you guys will have to. So any doubt? Yes, guys. Any doubt?
No, sir.
Please note it down, and then let's see if we can do some question. So this was the last one. Whenever you guys want me to cool down, then right. And remember, in some cases, always remember, in some cases, it would be given that there is some current flowing in this circuit, right? In this bridge, there is some current flowing. Then we will have to use these first equation, not the last one. R1 by R2 equals to R3 by R4. We only use that condition when the current in the galvanometer is. Okay, so remember this point very carefully. So this is a very crucial point to remember. Right. Whenever the current in the middle circuit in the bridge is zero, then we apply the Wheatstone bridge. Okay. Then whenever you guys get told down the system,
Sir, can you please
right? I oh I if IG is zero, then I1 equal to 5 and I2 equal to 1. Noted, right?
Done, sir.
Mariam, what about you?
No, sir.